Hey everyone, welcome to the final series of this Rust and Bevy game development series. And in this series as well, today is just going to be more about how to proceed with what we've been trying to implement for some time now. So generally what we started with the basic concept of Bevy and the RCS. And before I continue, I want to give a big shout out to everyone that has been consistent all through the series. You've really shown commitment, and that is a really that deserves an applause, right, from my end. So I really appreciate that, and appreciate your commitment, both on a personal level and based on the fact that you could come through from the first day to the last day of the series. So yeah, thanks so much for joining all through the seven part of the series as well. So today we are going to try to round up or wrap up what we've done from part one to part seven. So today being the part seven is going to be just improving on what we've done so far, right? So like I said, we started on from part one, we just discussing about Bevy and Rust generally to give an introduction on what we needed to do. And from there, we just continued doing other stuff. We started with what ECS was and what to understand about the ECS paradigm that Bevy employs, why it does employ the ECS paradigm, and every other thing that makes a lot more sense or that is quite important for our use case, right? Those things were crucial. We needed to talk about them, and we did. So we did that for a while, and um, even though there was no practical stuff on the first day, which was the first part of the series, we were able to implement something that worked. And then we did that for the first day. Then also for the second day, we did a bit of practical, right? And we we use that as a pointer to what we wanted to do. That's the implementation we desired. And so, yeah, we did that a lot. And from there, we proceeded to, after learning about the CS, the renders, the components, the systems, the um, what else? The entities. Yeah. So we proceeded from there and we moved on to other concepts. And then we started with our first 2D implementation where we took some of the examples from Bev itself because we didn't want to reinvent the wheel. So we started with very basic stuff, just rendering meshes, loading the camera first, then rendering meshes. Then after that, we proceeded to other concepts, other important things that we wanted to, or we're supposed to talk about or to show, or to have knowledge of before we could dive into more advanced concept of Bevy. So we did all of those things, but we couldn't complete it. So after doing that for a bit, we jumped into other concept, which was the third day, more like an advanced concept, which is implementing the bloom functionality, which we did, the 2D bloom. So we implemented the 2D bloom. It was just basically shapes that we added bloom to just give. And then after we implemented that, we wanted to extend it a bit, and we implemented other functionalities like understanding how translation works, understanding the rotation, and then we added more concept to it. So it looks like that's the light source. And then from there we proceeded to part three of the series where we did a bit more advanced concept where we talked about sprite. We handled sprite and sprite animation in day three, which was the part three of the series. But we learned other things along the way like rotation and also pixel grid snapping. We did a touch on that a bit also, and we talked about most sprite, basically about transformations. We talked about transformation, and then on part three we actually covered sprite animation basically, and then we got introduced to the 3D concept, right? 3D scene where we rendered our first scene, which was this. And so on day four we started with the first 3D scene, and then we implemented a 3D world by combining the example. We didn't have different examples running. We are trying to now combine them. Since we are learning, we've known the concept, the syntax, the semantics of the language and the framework. All we needed to do was just to improve on them by using what we wanted and the implementations to make it work as supposed to. So we did that, and then we did the 3D viewports to world implementation, whereby we used that and it worked. It made a lot more sense. And then from there, we proceeded to other concept, which we also implemented, talking about, so basically it was just more about the 3D. Then after we talked about that, we went to the light maps to see a bit of light maps and how to load certain models to render very real life like scenes, like the showcase, the light maps that we implemented. that we showcased. That was in part 4 of the series as well. Then we moved on to part 5 of the series where we implemented, we tested a lot more things also. We moved on to part 5 of the series where we now implemented other things like the that was when I went to, okay, we showed a lot of things on day 5 initially. We showed a lot of our animations work in 3D and a lot of concepts we learned in 2D, but bringing them into the 3D world. And they were not really that much of a difference, just to give us an idea of how they work. So we implemented that as well. And then it made much sense implementing that and using that as our pointer. So we did that and it was quite interesting. Then we talked about other things where we now started with our game directly on day 5, right? We started with our game on day 5 and we built a game on day 5. First thing we looked at was observers. Before building our game, we looked a lot about observers because building games require you to be able to trigger certain things based on events, right? So you want to observe things that happen within the world. So we understand the concept of systems, systems and components and entities. We understand that we have the startup, we have the update schedulers for our system. When we are adding, chaining them to the app to define how they are being executed when you run the program. And then we needed to also understand how observers work because you need to observe things within the system. You cannot expect everything to render per frame. You want to listen for different things like button clicks, even while there are a lot of other things working at the same time. You want to listen for when someone clicks this, or when someone moves this, or when there's a collision, or when there's a collision between two objects that should trigger something entirely different from another object colliding with another object. So we wanted to understand observers. So we did a bit on observers. We touched on observers, which was this. So we learned about observers, which was how we implemented this game-like scenario whereby when you click on any of the bubbles, it cascades to any of the bubbles around it, and then it despawns. Learn about despawning on, and then move from day 5, and then we moved to implementing a very simple game menu on day 5, which was this game menu. But and what we did was now we implemented this, we saw how it worked. So on this in day 6, we now no day 5 actually, we still made a bit of more. We added the observers and the game menu. We combined them to see if you can make a game that will work by combining both of them. So we did that and it worked in day 5. And we were able to render a screen whereby you have a game menu and then you can move from the game menu, move to this observer with all the observer code intact. All we did was just to render because they are two separate applications. So we imported the observer into the game menu by making it a plugin. We learned how to do that as well. And then on day 6, which was the previous episode before this one, what we did was to now implement the breakout because we wanted to apply everything we've learned so far, the observers, the despawning of entities from the system after you spawn them, the camera movement, the collision. So we wanted to learn about collision. So we talked about collision, we learned about the physics, we did a bit of diagrams to represent all we've learned over time. When we did the sprite animation, we talked about this diagram. When we talked about the collision yesterday, we wanted to understand how collision works. And I explained that it's basically two concepts that we needed to understand. Bounding. So the reason why we needed bounding is because everything is bound by something, right? In this case, it can just be, for instance, now let's use the simple shape as an instance. This is a circle, right? There's a bound to this circle, and we can extend the bound to this circle to be this green. So we know that whenever something touches this green, based on the position of this green, then we can say that yes, something is close to it. It's just simple mathematics and physics. So we understand that by being close to something means your entire dimension of whatever object, whatever entity, if it is close to the position of another entity's dimension, then you know that they are colliding. So it's basic. So what we needed to do was to implement a bounding rectangle and a bounding circle. We use those two concepts to determine if there's a collision and if collision has occurred. So we spoke about that yesterday. We implemented that and we used the breakout here. And basically, it was just a basic implementation from here, from the example. So we extended the example and then we created something much more interesting. So let me show you guys what we did. So what we did yesterday was to implement the breakout and to extend it to become better than it was previously, like to give it more flesh, more life than what we had currently. So that was what we implemented and it made a lot more sense, right? So we're able to add different colors, we're able to add the timer, we're able to add the game loop, we're able to extend the game loop by ending the game when all the bricks are out of it. We're able to understand the collision calculation and implementation. Basically, we saw that in the code base. We saw how to increase the movement of the ball and how to increase the dimension of the padding of the paddle itself, how to change the bricks to different dimensions, customize them, how to implement other features into the game, like how to add a menu, a pause menu, like a game menu, which was not there initially. So we implemented a game menu that works and that renders on top of this breakout, not as a separate screen, but just as a node on the breakout that actually works and that you can render when you press like the escape key, right? That basically takes the that basically renders the menu itself as a transparent with a transparent background and shows it on top. So I'm just going to show you guys what I mean rather than just explaining everything here. So this, let me just run this again. So we have an example to showcase. Going to main.rs, I run the main function. Yeah, we have this. So we did a lot of those things, especially on the breakout. The breakout was a lot of extensions. So then from day 6, from part 5 of the series, we started looking at how to use AI to improve our workflow, right? Because this is our new new way of everything we do right now. AI has to be incorporated. So this was what we did for the part 6 of the series. This is, and this, looking at this example, this is the actual example, right? Let me show you guys this in the new app. So this is the breakout one that was the example we got, and this was what we implemented the example to. So we implemented this as the example. We improved the UI of a lot of things. We made the boy a bit faster so that we can render this quickly. We modified each row of the brick of the obstacles to be different colors. We added the if I add this, we added this menu system that I was talking about, and that you can resume, restart, or quit the game. Quitting the game entirely stops the game. So we added that. We added a lot of other things, so we can stop the game loop and proceed the game loop. Right. This we added this also from what we've learned so far. So we added the restart functionality that restarts the game basically. So we add that, and so when the game is complete, also it gives us, oh yes, the game is complete. So this didn't have all of those things. The original implementation didn't have that. So what we did was to extend the original implementation by extending it with different things, making it a bit cooler and a bit more modern than just an example, something you can play and have fun with. But even though it's not fully complete, it is something that you can play around with. So this was not the only thing we did. This was the one we the one we've done in part 6 of the series, but we implemented something else in part 5 of the series, which was our observer function. And observer implementation. Okay, let me remove this. Let me use the main example, the main. So if we render this now, we should get something entirely different. So we will stop the previous one that is running, right? Just to show you guys the new example. So the new example works differently, right? It doesn't have this whole beautiful implementation. Why? Because we're taking it step by step, and we wanted to see how we can improve it. Also, we leverage AI here, but guiding it on how to implement it because we needed to understand what to do. So these are just like recap of what we've done so far from part 1 of the series to today, which is the final part of the series. So yeah, we implemented this for the game, right? Based on what was done initially, we added some other things like we paused the game loop, we escaped the game loop by taking it back to the menu, which was a bit more the different concept. This takes you to a different screen entirely and everything. But in this one we did, or in the breakout implementation, not in this one, we implemented different concept like managing states so that we can control the game menu itself, pause the loop, so that while the game is not running and different things that we're able to do. So this is how the code looks like. A lot of other functionalities, and it's a lot small code, almost 1,000 lines of code, but it worked. We understand the ball collision, we saw the functions, we saw the physics, we saw all of those things work, and that was how we were able to get all of this to work. Right. So basically, this is what we did from the first part of this series to the part 6 of the series. So today being a part 7 is going to be our extensions, right? It's going to be basic extensions of everything we've done up till date. So it's going to be what we've done, how did we implement it, how did we resolve all of these things, what did we do to fix it, right? So all of those things are going to be done. So we are going to implement all of those things and see the result we get from all of this implementation. So basically, this is interest today. So we're going to use implement more functionalities to our existing functionalities, because we basically have covered almost everything that we need to like start with game development using Rust and using the Bevy engine, right? Or generally game development. This exposes us to different concepts, right? Like how to work with a lot of other functionalities you will see in other game engine or even other physics rendering engines, right? So it introduces us to a lot of those things. We see the user interfaces, how to implement box shadows, buttons, and windows, and all of those different things. But you really don't need most of these things for now, except you would need them for maybe implementations. Then you can implement it and see how it works. So that's basically what we've done. So today is just a way of saying that okay, we want this to work, or if there are any questions so far on, oh yeah, this is what I need to do, this is what I need to work on. I have this question regarding this. Now is a good time you can drop that the question on the chat, and then we can reply to it and see how we can tackle any of the questions. But if there is none, what we're going to do is to pick ways to improve on what we've done so far, right? So what we've done a lot. Like what I showed you guys just now is a very important implementation. I mean, the brick, um, the breakout game, right, is something that people have implemented for years now, and it's even I'm sure it's even still being played by millions of people currently, right? You can get it on Play Store, App Store, literally as a desktop application, right, and play all of these games with different levels. So, and one of what we are trying to do is not just to wrap up with what we've done so far, but try to implement it, see how much you can, um, see how much you can, you know, work ourselves. Should I use that word, work ourselves? Or let me say, basically, see how much we can go in our implementation. How much can we, what's the level, what's the scale to which we can get to for this implementation? So let's say I decide to improve on this breakout game right now. What is that thing I can improve on? Or what is the limit we can go to implement something crazy with our current knowledge? So, but the idea is that we are not using our current knowledge alone to view, because that would be like a lot of time. And interestingly, AI has reduced our time of development and our time of understanding new concept. So basically, even if you did not understand new concept, we use the AI to implement a lot of features that I showed you guys early in this game. Things like the um the menu system, the menu that was displayed, the menu display, the menu UI that was displayed, that rendered that transparent menu, right? And pause the game. Everything was done with AI, but I want just giving it instructions and watching the instructions, right? Because it made a lot of mistakes to while we implementing it, which if you go through the live stream yesterday, you realize that there was a lot of mistakes that we needed to fix little by little by little. And we're not just fixing it yesterday. We are like as we so we're also making fixes to the implementation. We're also guiding it on no, don't do it this way, do it this way. So we want to extend and see what we can do, right? This doesn't mean today's lesson is not just about implementing something that works, it's about seeing it's about challenging ourselves. Yeah, that's the word. It's about challenging ourselves to see what we can build. So say you have trial knowledge, or you don't even have trial knowledge, or the only knowledge you have of Bevy and Rust is watching this series. What can you do with it? Can you improve on what we've done so far? Aside from this breakout game that you can see on screen that plays itself and that implements collision detection, that implements different concepts like movement. I want to add a bit of power ups to this game just to see what happens. Right? I know power ups require like assets, but we're not going to use assets in this case. We're just going to use stuffs like numbers to see. Like before you implement any complex thing, it's always good to have a prototype. So I want us to implement like a prototype for our game to see what we can do, challenge ourselves today to see what we can do with AI. Because like I said, I always I've been saying it for like for two parts of the series now, for part five and part six of the series, that you need to start using AI to build those stuffs. And I'm not going to shy away from saying it. It is very important. You cannot compete nowadays if you do not have that skill and that knowledge. So I'm not shying away from saying you have to write everything and understand the entire thing. No, definitely not. That is not going to happen because you cannot understand the entire thing. At least for now, you definitely cannot understand the entire thing. What we've just done is just like few hours of covering Bevy, but you don't need to, because that's the beauty of it. You do not need to. You can simply implement basic things like we've seen. And I showed you guys a lot of other things in the assets that you could pick that people have implemented and they've shared their implementation using shaders, like actually making other things like even a wasing game that runs on the web, right? You could do that, but that is not our own. That is not our focus for this. What I wanted to do is just to build a desktop game that doesn't require us installing other libraries to work with, just what we've known so far. So that's what we are going to be doing today. So what we're going to do is we are going to improve this. So two things I want us to work on to improve what we've done so far is to like I said, challenge ourselves to something a bit more. So what is that going to be? We are going to be doing working with this. We are going to be asking. We are going to be using AI to make some changes for us or add some features to the game. The first feature I want us to add today, which is going to be like a bit more challenging even for the AI. But let's see how far we can go. Let's see if we can actually make improvement. Let's see if we can do something different than what we could by our own self, and see what we can get out of it. So let me show you guys something first of all that I have um, before now, but I never run it here. So it's basically this. I'll use the menu main and yeah, I think I removed the mode. Yeah. So this says main is not private. So in this case, say I want to run this, right? I have this. So there's this code that's okay. I don't know if this is going to work yet. I've not really like tested it, but this is something I just wanted to show you guys. This is a simple implementation that I saw or that was done that I just wanted to share. But I don't know. Like I said, it might not work fully as I expect it to, but it's worth showing you guys. Okay. So yeah, it was supposed to load something else entirely, a different game entirely that was like written, but like I said, I'm not sure it was going to work. So let's leave that aside. So we are going to improve the breakouts. What we also do in the breakout is simple. We will start with two things. Number one, we are going to add levels to our breakout, so that when you complete a level, let's say you complete a level 1, you can move to level 2, and then that keeps track of your high scores and everything. Now, I know this is going to be challenging. Like I said, it's going to be challenging. But the reason why I want us to do this is because I'm not going to be writing this also. You are not going to be writing this also. But to teach us how to implement a level, yeah, something that more advanced than what we've learned so far. How can we do that? How do we implement it? How do we even start it? Say you have no idea about how to start it. What do you need to do? What's the first thing? Do you even have an idea how to build levels? We've not talked about it. But let's use something that is able to write it for us, then learn from it, right? So today, that's what we are going to be working with. So we are working with using AI to implement levels to our breakout implementation. So I believe this is still, you guys are still here and we are still learning together. So basically, this is what I'm trying to implement today. And given this, going back to where is that? The game, right? Going back to the game now. Okay, so let's go back to this. So we are going to add levels to our breakout. Like second thing we are going to do is we are going to add power-ups. So the power-ups we are going to add at different types. I'm going to start with 3 power-ups first, and they drop periodically. So power-ups that drop periodically for the paddle to collect. Or two things. It's either the power-ups drop periodically or the power-ups are embedded in the bricks. So if you break a brick that have a power-up, I think that's a better idea. So if you like smash a brick that has a power-up, you automatically collect that power-up and it automatically works on whether the paddle, if the power up is for the paddle or for the ball, it depends. Like these are options. We don't need to complete the implementation from scratch or say, oh, we are doing this 100%. No. Now, I don't guarantee that everything we are going to do today is going to like function, but then we'll learn from it, right? Because this is a bit challenging even for AI. So imagine if you had to implement this ourselves, it would take us days and hours, and we will not like to stay on the call just looking at us battling that. It's not a good look, right? So, like I said, this is what we are going to implement. So, we are going to add power ups second that drop periodically for the paddle to collect. So, the third thing we are going to drop is we are going to add add levels to our game, add power ups. So, let's not use the one that drops. Let's use power ups that are tied to different bricks, right? So let's choose a power up. So let's say the first power up is um long long paddle. I think I'm using the the knowledge I have from like playing a breakout game initially. So there's short paddle. So that means we need to make the paddle no longer constant in terms of the width or the length of it. So the width of the paddle, we need to now make it not constant, because if it's constant, we can't change it. But because it's not constant, then we can mute it and then make this to work. We are going to see that in action, right? I'm just pointing what you should expect from this. So we want to add power ups to different bricks to to show that okay, the first power ups are going to be tied to brick. So when you break any of the brick or you smash any of the brick and or collide with it, let me use the word collide because that's what we are working with. So when you collide with any of the brick, you get the power up in that particular brick, and it applies to either the paddle. If the power up is for the paddle or the ball, it automatically applies. So we are going to have bigger ball. We are going to have smaller ball. We are going to have faster ball and slower ball. Now these are power ups. Now currently we have 6. I want more. So I'm going to have one last one. Then maybe if you think of more, we can then implement it. The 7th one we're going to have is clear fireball. Now fireball is just to clear. Let me close this. So fireball is basically fireball to clear all bricks it encounters. So now for us to implement this, 2 things needs to happen. I need to actually implement a VCS because I will not implement something like this with AI without having a backup. Definitely not. So these are the 2 things I'm going to add. So the first one is going to be levels to our breakout game. The second thing is going to be add power-ups that are tied to different bricks. The long paddle, the short paddle, the bigger ball, the smaller ball, faster ball. So these are going to be the different bricks that we're going to add to it. So let me leave this like this. So we are going to be giving it as instructions to the AI. So let's stick to this. So let's see how best you can implement this. So in this case, we are going to implement a system. Let's start with the level system. The levels will give us an idea of what to do. So if you can implement the levels completely, we can add the power-ups to different levels. So the power-ups now being available or not being available, we make it like I think implementing the power ups will come first because that way it makes more sense. We don't need to deal with different. Let's start with the power ups, right? We are going to implement the power ups. So I'm going to tell you to add these power ups to the implementation. So let's start. Let's start with this, see what we can create from here. Okay, I need to find a way to increase this thing. Why will you not even increase with the system font? Why you just okay? So let's go back to let's just try it. I don't know if this is going to work yet, but let's try. So okay, first of all, like I said, we need to implement VCS. So what I'm going to do is just create a repo and then like just add that. Even if I don't need anything here, I'm just going to like add it to VCS automatically. And okay, so let's do this. They are on version 5 here as 78 automatically. So I'm going to go back here, automatically adds one stuff for us that we can use. So I'm going to remove the ID also. So I should have less files. So I got 38, but the actual files I need. So I'm going to add this to VCS automatically, create a message for it. Okay, I cannot generate a commit message. Can I generate with this? I should generate with that. And then from there, okay, I do not like this message at all. What's up, code? Do I have access? Do I not have access? What is happening? Am I missing something? Okay, so I'm going to use this first of all. I'm going to use that as my don't share yet. I'm going to be working with it one by one. So now that we have that commit, we have our commit ready. So I'm going to close the git ignore. The first things first, we're going to start with implementation. So the first implementation we're going to start with is I want you to implement this, right? Like I said, let's plan how this is going to work. So first question I'll ask is, are you familiar with Bevy engine? Okay, I need to find a way to increase this. I can't really do that because I don't know how to increase it any more than I'm doing right now. I've gone to the system, I've gone to the settings to increase this, but for some reason it doesn't even want to work with that. I can't seem to increase the window itself. So yeah, probably need to use another one automatically. Okay, so let's see. What do we have? What do we need to implement? Just trying to see if I can improve the size or increase the size, but I don't think Kilo has that. Okay. First things first, I want to remove something I don't need. So we implemented this game the other day, the menu rather. Not the game the other day, not mistaken. And that was what I was trying to show you. You know what? There's no need for this. Let me just leave that. So what was done in so let me first ask this question. Let's see if you understand what was done in the game. So if you can explain, oh, this is what was done in this game. Yeah, so yeah, it's already suggesting power-ups for me that drop from bricks, which makes sense. So that's exactly what we are trying to do. But then I want it to do it the way I want it because allowing the AI to suggest for you, suggest it in a way that it might not be able to complete or implement. That's another hack. Don't let it always suggest. Let it give you the idea, tweak the idea to fit what you want, and then give it back to implementation. Like I said, all AI are just garbage in and garbage out, but it's smarter garbage in and garbage out, just the same way. AIs are dumb but smart. It's a very complicated thing, but that's basically how they are. So it's already giving me suggestions now that I think we can work with. It's giving me power-ups that drop from bricks, multiple levels with different brick layouts, which is exactly what we want to implement here. So I'm just going to copy what it has written here, that power-up. So I'm going to copy the exact way it has written it. I'm going to create. I'm going to check if there's a README file. There's no README file, so I'm going to create a basic README file here, and no, not a Rust file. Nope. I'm just going to create a file and call it a readme.md, right? Which is, I know it shouldn't be in the readme, but I want to leave it in the readme for now. So I'll just do two things. Features. I know that rhymes. So features, we are going to say add power-ups that drops from bricks. That's number one. Number two, implement multiple levels that with different brick layout. Number three, add particle effect for brick destruction. Now this will be cool to see when you hit the ball. You want to see its effect, add that effect. There's already sound effect. We don't want to do that. Introduce now. I think this is another interesting one. Introduce different ball types. Have a type error here. Ball types or behaviors. Then the last one, okay, let's assume these are just what we have. So I want to use the power up, right? I want it to because it's going to here's how I want to implement that. So I already have my instruction, right? On how it should implement this. So let's see if you can get this working. So like I said, today is just going to be about creating stuff, like learning new things by leveraging AI to add stuff for us. Now it doesn't need to work, right? But we learn from it. We learn how to implement levels. We learn how to implement different layouts. We learn how to implement power-ups. How do we have power-ups? Now, it already has a plan for how to implement that. It says, plan for implementing power-ups in the breakout game. One, define power-up in normal component type, yeah, and velocity for falling. Now, it's trying to implement the falling approach, which I said, but do we need the falling approach? Can we tweak it? Because that was what I was thinking about initially. But I don't want it to have falling approach. The falling approach is quite meh to me because you need to start thinking about collecting all the power-ups that drop. Typical thing that works right for other breakout games, which is cool. But for this one, we do not want to go that route. We want to go a different route, which is the point we are trying to pick out here. So that's that for that. And next thing is add power-up spawning system when bricks are destroyed. Modify brick spawning to randomly assign power-up drops with probabilities. Okay, so that's another thing. Power-up drops, I think, will be more complex. I'm top of my head, I feel it's going to be more complex to implement than just adding the power ups to the brick so that every brick itself contains a power up. That way it's easier to do because the bricks already is a two-dimensional array, right, of rows and columns. So because it's a two-dimensional array of rows and columns, we can just assign randomly any power up to the array uniquely, so that we know that there are no two power ups in a particular brick. That makes more sense and it's easier to implement than implementing a drop with for all the power ups. So once you hit any brick, you know that you already get the power up instantly. It does not matter what. I think I prefer that. Yeah. So but that is downside to the downside to that is that you always need to collect the power up, even if you don't want it. So I think that's more challenging. So you don't need it, but you can't still collect it, and then you have to be smart to whatever comes to you, find your way to like navigate. I think that's more challenging. Personally, to me, I think it's a better approach. So add power up filling physics, apply velocity for power ups, add collision detection for paddle catching power ups. That's the thing. Paddle catching power ups is the default way of implementing breakout. Let's tweak it a little. I don't want the previous default way. Let's make ours a bit different. Implement fireball logic, destroy brick on the contact without bouncing. Yes. Add visual sprite or meshes for different power up type. Yes. Add timers for temporary effect. Definitely. Update restart logic to reset all power up effect. Perfectly okay. So these are perfect except for the things we don't want. So two things I'm going to modify is this. Now, for the first thing it has implemented, which is the power up setting and everything, which is fine, it's totally okay. But we can do more. So we don't want the approach is going with, we want a different approach. A different approach in the sense that we want it to go another route, and the route we want it to go through. Okay, let's proceed for now. So we want to implement a different approach in this case. So I would say I want to change the way the power ups are being assigned. I want it such that power ups are tied to the bricks, so that when the ball hits a brick with, or let me say collides with a brick with power ups, the ball or the power up is automatically what's the word, assigned to either to the entity that needs it. Can we implement this approach instead of the drop power up drops? I feel this approach is, I believe, not feel this time around, this approach is simpler to implement since we can just use the same to the array, or let me say to the vector of the rows and columns of our bricks. Do you understand this? So this is what we are trying to do now. With this implementation, like I said, we are just trying to see what we can create, something new, something different from the examples we've done so far, that we can learn from, that we can say, oh yeah, I learned how to do this, I know how to do this. Can you yeah, I know how to do this, I understand how this works, I understand how this is meant to be implemented. So in this case now, I think he already has a way of implementing it. Now it has revised the plan to using the defining power up enums, which is the LongPaddle, ShortPaddle, BiggerBall, SmallerBall, FastBall, SlowBall, FireBall. Those are the 7 power ups. You can add more as we go on if we successfully complete this first implementation. So the second thing is add power up components to bricks during spawning. Perfectly what I want. Add based on row or random. So in this case, the power ups are going to be like random, but it's going to be unique so that the brick does not have to power ups. So modify the check for collisions to apply power up effects when brick with power up is destroyed. Exactly. So implement effects application function for each power up type. Modify the parallel paddle up properties. Exactly. That's perfect. Okay, yeah, that works. Add timers for temporary effects. Definitely. Implement fireball mode. That's the ball destroy bricks without bouncing. Exactly, because it just goes through any brick that it touches for the time that it is active. So implement the fireball mode, yes. Update the restart logic. So we are still on track. This makes sense. So I'll now confirm if you understand I'm using the version of Bevy. So it might not be trained on that version, so it won't go doing something else with the previous version and then spoil the entire thing. So I want to be sure that you have a solid uh, knowledge base of the latest version of Bevy engine, because it is crucial that you do. So because of this, I have to be sure that it has that. So if it tells me it have that particular one, I will changes like we always done. So we need to make changes. Okay, whether this is valid or not valid, we just want it to work, right? And what if it doesn't work and then probably the AI hallucinate for some reason? What we can do is we can tweak it and fix it like we've always done, right? So yeah, so that's what we are going to do today. So it says, yes, I have a solid knowledge of Bevy engine, including version 0. This use Bevy features, the SES component, blah, 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 this, that, branch ready foundation. Okay, what will you start with? How do you plan to start to begin the implementation? So how do we begin the implementation? I'm asking it what it needs to do to begin. So they even ask me, do you confirm my code? Ask me to confirm code before starting. So what we're going to do next is just leave it for the next few minutes. Let's see what it's going to create. So it has started creating stuffs. First thing we've noticed there is it created a resource, right, for active effects. That is important because we need to know which effect is active. That means we should be able to use multiple effects. So let's say we hit a brick that allows the paddle to grow, and also hit another brick that allows the paddle to shrink. Which one takes effect? Now, this is where I'm beginning to regret beginning to regret using this implementation, because and that is why I also like it, because that way you cannot predict what you get. You don't have the choice, you don't have the privilege of choosing. We are trying to learn from here, so let's learn with this before learning about the drops and the velocity implementation, which we can also implement for something that's entirely different. So let's proceed with this. Let's see what it can bring. Let's see the challenge we are giving the AI to see if it can match our challenge and see if it can successfully create it. Now we can see it creating the apply power up function that applies the effects. And I think I like the way it created this, yes, using proper enum types. That makes sense. It's following the patterns that it should for a proper Rust program. And that makes a lot more sense. So the next thing we can see here is it added the the effect, how to update the effect. He added that function also. And if I'm not mistaken, that has been perfectly implemented. I actually like the state of the code I see currently, even the function names and the way it is using it. Check for collisions, applying effects, effect timers, and what else? Let's see. Long paddle, short paddle. Yeah, this is cool. The brick color, change brick color. Okay, yeah, this was what we did yesterday based on rows. And now we have the power up for the power up defined also. Okay, this is outdated. We are going to change it to something else. Random pool. Yeah. Uh, this will change to random pool. So it's still the same thing. The signatures are the same, so nothing changes, nothing is destroyed. So this also is changed to random range, if I'm not mistaken. Yeah, random range. So we have that. Like I said, nothing changes, it's just deprecated. And yeah, every other thing seems to be fine except for this. The timer should be is finished. Yeah, it's finished. So we change finished to it's finished, and everything should still work fine. So it's finished. It's perfectly aligned. Let's look for the last thing we might look at here, which is I think it's duplicated. Yeah, duplicated code. Okay, fine. Let's see. There's a menu entity here which is double. So you basically just copied and used that. Okay, I'm not even going to question that. There seem to be no error so far, so that means everything works perfectly well. So let's try to see if everything is fine here. Let's try running this. Let me ask you to run it since it has started this. Please run it in the right place. Don't run it in the wrong place. Come on. You've been doing everything well so far. Just don't misbehave at the end. Update the to-do list, this and this. Okay, let's try it ourselves and see what we get. Let's see if we get errors or if we do not get errors. Okay. Yeah. First thing we notice, the game doesn't start. But then we can learn a lot of things from it. We will still learn from how this works. First thing we're going to see here is there's a duplicate, right? We can see where's it? Conflicting queries. Yes. So what I'm going to do is paste this error back in. So there's a duplicate of it using disjoint query somewhere. So which is where you see we using you've seen this error before, if you remember from the part two of the series where we had issues with and without, right? We can actually implement that fix. Let's see. But let it try to update effect. So update effects, there are two. There's an implementation for it, which is a function, and it's talking about the query here, which is the query mute transform velocity with ball. So in this case, they say that consider is in effect a conflict in a way with the previous system parameter. So we can use the with ball and without paddle in this case. Paddle. Yeah, this doesn't seem right. Let me read through this first. So the thing is transform here, transform for paddle, which is transform and with paddle. Then we have the transform velocity with ball. Two separate things, right? Okay. All right, this works, but we need to use this. We need to remove one of them, right? Because we need to remove the disjoint queries. And in this case, what we need to do is similar to what we did the last time. But we need to use the without ball actually. We cannot implement this without specifying the without ball. We need to. Without paddle. Actually, it will be here. But it's going to throw an error because wrong number of fragments I've expected to at most found 3. Wow. So you remove that. The query is supposed to be it's supposed to take 2, so we need to add it inside here. That's without paddle here. Let's see if it works. Of course, it's not supposed to work, but it's crash. Let's see. Yeah, it should crash. What? It didn't crash. Okay, now it didn't crash, but it doesn't display the paddle, so we can't even start the game. The ball doesn't display, the paddle doesn't display, obviously. So yeah, that means we've made progress here, and without paddle, in this case, let's see if this works because we've moved it to because no, there's a problem. It says okay, there's a way to implement this also. Okay, hopefully this should work. Let's restart this. Let's see, what do we get? So this shouldn't crash. It should work. Since we've already defined that, I should remove that. But now we can see we have okay. So it worked the first time. So we see we have that missing. Our paddle is definitely missing. Even though they are power ups, there's no way to test it. There's no way to know. But the essence of this. Oh, now it's back. So it took a lot of time to spawn that. Does it work? Yeah, it does work. But our ball is frozen. So that means the translation or the transformation we apply to our ball for movement is totally broken. Yeah, we need to fix that. But then we are not going to fix it ourselves. No, definitely not. So what we need to do in this case is to understand what was done initially. So let's see. 3 things basically, if I'm not mistaken, was done. First thing was to add the resource. In this case, he added the resource duplicate code fragment. Where is the duplicate? I need to see it. The issues had duplicate twice. Okay, I want to restart also at the timer and stuff. Okay. All right, that's fine. So we add this, we implement the paddle timer, right? We add it to like maybe to determine the size, the paddle, the fireball, and all of those things for the timing. So we can actually revert or reset them back to the original stuff that we had. So that's what we were trying to implement. So in this case, that was our plan, and that's our plan for now. So interestingly here, because we have this now, we have all of this. Like I said, this is not to like get it to work totally. It was working before, but we want to learn new concept. How do we add power ups to it? So we will still get the power ups to work. We definitely need to get it to work so we can see it. But we need to understand that aside from what we've learned so far, what is possible outside of our current knowledge base? What we can do is to leverage AI to make that work for us, which is what we are attempting right now. So in this case, now what we are doing is we insert the resource first of all, which was the first thing that was done, and the timer for all of those resources have been added. First things first. The second thing we did in this case was to implement for the fix update, add the apply velocity. The fix update runs similar to how the update works, but remember the fix update is more like for that should run at a fixed rate, right? Things like physics, networking, all of those things should run at a fixed rate so that you do not get this what's the word to use now? So just make sure it runs like smoothly and doesn't give you like all this breaking, no, not breaking, that's not the word, but just to make sure it runs smoothly. Like it's fixed update is a much more okay, just a way of controlling the rate at which it runs, like the frame rate, the refresh rate, and all of those things. So like all this, the time it takes to avoid flickers and all of those things. I'm trying to look for the word and place the word, but pardon my loss of words right now. But basically, we use fixed update for the velocity because according to the doc you see says example of system that should run at fixed rate includes physics, AI, networking, example of them. So now we see the velocity also is added. Velocity is in this case, and collision is also physics. Update effect is physics. So we change the system together to run them in order. So apply physics first, move the paddle next, check for collision, then update the effect, which was actually the way we wanted it to work, right? And that's basically what we have. So now it means something's actually breaking, which is why our ball doesn't move, but our paddle moves. And we can see from here that we have these colors implemented. So without the ball moving, nothing can be done. So currently there are no removal from our code. It's only just additions. We can see there's no removal. If you look at the colors here, there are no removal, just additions. So that means something has been done that prevents something else from working. So let's look at the second change that was done, which is the important one, is defining the power-ups. Now we are trying to implement power-ups, and how do we define the power-ups, right? The first thing we want to do is we are implementing our power-up type, which in this case is defining what the power-up should look like. We implement the paddle next, the short paddle next, the bigger ball. Remember we created all of this and said create all of these 7 different power-ups for us. That's what we intend to use. So the next thing we did was after implementing all of this, we created the struct, right, from the inner that was created. Remember, we derived all of this because we needed all of them. We needed the traits to use them. Clone, copy, debug, partial equal to, so that we can make comparisons. And then we have the resources. That's for the active effect. Now, all of these things are defined just to be able to control the power-ups that we've defined. That's the essence of all of this. So we have other things. Okay, let me make this. This is deprecated also. Trade RNG is deprecated. Need to rename to RNG. Just RNG is fine. So random number generation, that's what RNG is. So yeah. So this is okay. So we assigned the power-ups to the different bricks. That was what we suggested. That was the implementation we suggested because that seemed a bit easier for it to implement. So that whenever you break any brick or you crush any brick, it's automatically assigns you or randomly assigns you a power-up that you can use. The power-up it assigns to you is what you can then you automatically have, not just what you can choose from, is what you have by default, whether you want it or you don't want it. Not because you get. Now, it makes it more engaging because whatever you have, what you have, you need to be able to make use of it to do something to achieve your goal, which is to complete the level or to win. So we added all of those things, and then one more thing was added there, which was the mutable reference. Remove this since we are not mutating. So we for our bricks, because when we check for collisions we need to check if that brick has an effect already exists, or let me say the effect exists on the bricks. So if we click on our brick in this case, and or let's say if we hit any of the brick or collide with any of the brick, if the brick has an effect, what happens? So this is where that is being considered. So we implement the collider query here, which is what we have here, and then we say that, okay, apply power up effect if it is present, right? Remember this, if it is present on the break. And that means we apply the power up effect. So that means we have a new function called apply the power up. We get the power up that is being affected. And the active and the effect time as it was is being passed to the function. We'll check the function eventually to know what it does. And nothing much changes, just update at this point. So updates has been done here. Then a new function was created called apply power up. So in this case, it gets the power up type, active effect, and that. So first thing we check is if the power up type is a paddle, long paddle power up, increase the paddle size multiplier by 1.5, and then reset the effect timer. So that means for every effect we implement, that means there's a reset, right? There's for every effect we are given or we get assigned to either the paddle or the ball, there's a timer for it because it should not last forever. It's just temporal. That's why we call them power up. So it's just to use for a temporal for a short period of time. Before we implement the level system, this because basically what we are implementing now is the power up system. We will implement the level system eventually, but let's implement and get the power up perfectly working first. Then we come back and approach this. So after working with this, we are still going to use AI to complete this, right? Because we are not working, but we understand what is happening here. We can read the code. The most important thing is your ability to be able to understand what has been done and to see if it makes sense. And if it doesn't, to say, no, okay, make this change here. But so far, so good. Everything I've seen here makes much sense. And I believe the reason why it's not working is just some things are not just being added. And what we need to check that is we need to check the ball, first of all. We need to check the ball, the starting position of the ball. Was it changed anywhere? Because we know that we define that to be the starting position. And currently, looking at the starting position of the ball, it stays a bit in the middle of this wall, which doesn't change much. So that is fine. So next thing we need to check is I need to check if it exists elsewhere. So that means we really have to um, we only have two positions in the code or two places in the code where it is being used. So that is fine. So next thing we need to check is the initial where the game runs. So we need to go to check our setup. So check our setup. Yeah, so let me go to setup. So check our setup to see if anything changed there. So nothing really changes because you can see there's no VCS update or changes. The only thing that was changed was adding this random number generation so that we can update the brick. Remember, this loop is where the brick is being spawned or generated. So we are randomly assigning the power ups to those bricks as well. So nothing changes here, like nothing should break here because it's just a basic loop with adding stuff to it. And how do we know it adds stuff to it? Just the same way we added color to different rows here by defining the row type and then assigning the brick color here. As you can see, by creating a sprite and assigning the color to the sprite, we already created the sprite for each of the brick before. We just assigned the color to them. That was all. So in this case, we defined the transformation for the brick, which is that's not what we are looking for. We're looking for the paddle itself. So that should not happen within this where we are looking at. It's not here. So the paddle works. We can move the paddle, right? We can move the paddle. So the code for moving the paddle works, and the padding between the paddle and the wall also works. So nothing changes. The only issue we have right now is the ball. The ball doesn't work the way it's supposed to work. So what could have caused that? That's a question. So the ball velocity, check for collisions. Before we check for collisions, something should be running first of all. So when we check the fixed update here, what did we apply? Let's see. We really apply the update effect, which is update effect should come at the end of it. You should actually run a entire thing first. Or probably should it come first because when we are chaining this and we are saying this should run in order. So what runs first? The first thing that runs here is going to be apply velocity to when the game is playing. Okay, update effects works, but I'm going to do something. I feel like it should come first and see what we have. I know this is a very terrible, I don't call it terrible, but then remember, this is just me trying to freestyle and flex my knowledge of this, which I don't think should do anything, should have any major difference. I really don't think it should make much difference. It's still going to do the same thing, but now it's actually rendering the paddle and the ball a bit late, which is weird. That should not happen. So the ball is spawned in the right place, the paddle is spawned in the right place in the center, but the ball refuses to move. So like I said, that doesn't change anything. So, yeah, so we're just going to take it back. Yeah, take it back to what we have here. Keep this here. Then look for, I need to understand what has changed from here, where the ball has been modified, because nothing seems to have changed how the ball moves. This is where you implement this setup. This is for the collision. Okay, so for the collision now, we modified the collider query by adding the power up option. That was the only thing we did. We also added the effect for these two, which is our new additions. Then we got the power up effect. This is normal. Then we applied the power up. Yeah. So this is okay. Okay. Okay, I'm going to do something here. Yeah. So I just need a bit of backtracking, right, to understand or reverse engineering the entire thing it did, just to be sure that the error is coming from where I think it's coming from. I'm not entirely sure yet. That's why I'm checking through the code. I can ask you to do it, but I'm trying to understand what it has done first of all to see if we can also place where the error is coming from our own code base as well, from our knowledge of this implementation too. Okay, so yeah, still doesn't work. And then I noticed something here. It doesn't stay perfectly in the middle. I think it moves, but then it stops at one particular point. So that means it does renders once, doesn't update per render, or maybe the translation just happens once. Probably we hasn't a timer. I know we're doing this somewhere. It's gonna get pretty. Okay, let's look at that. Let's fix that here. This is the only place this could have happened. Ball transformation. This is the only place it could have happened. The update effect is pretty new, so there's nothing to change. I'm going to take the one I commented out back. I'm going to leave it back to where it is before and assume nothing has changed, right? Because this is where this is where it reflects when it touches anything. Break should be despawned and increment discovered on collision. We already implemented this yesterday and it worked fine. These are new additions. Nothing has changed. Yes, nothing has changed also. Yes, nothing has changed. It's still immutable reference. Okay, that's fine. Let's see what should happen. So something, the build is successful, but when we start the game, nothing happens. Something happens. The paddle, I noticed two things. One, the paddle and the ball renders about renders few seconds after the break and other game and text entities. That's what I wrote. Entities and text are loaded. So we have the second thing is the ball doesn't move as it did before. Can we resolve this? Can you debug and fix this? Tell me what you intend to do to fix this. So this is just me asking you to do what he wants to do, right? So I'm trying to make sure we are fast because we've already gone an hour into this and we need to be able to implement this. We want to do that. We've learned something from this now, right? Nothing much has changed. What I want us to learn from is this other aspect, which is this. Now we want to implement two things, like I said. The first one is the add levels, but we've not gotten to this yet. What we are working with now is adding power-ups, right? And this, instead of having to do this ourselves, we're just giving AI the ability to do it for us, right? But we're also checking if it is right. And so far, looking at the code and from what I've read, it makes a lot more sense. At least I can see the changes and they don't seem too far-fetched from what should be done. So asking the question to look at that, two things have happened. So there's a regression in the game because the regression had to, the ball doesn't move anymore, right? And the paddle renders very late. Paddle and the ball renders extremely late. Tell me what to do before you render. That was very, very, very specific. It went ahead and just started writing for me. Let's see what you did. Apply velocity for the chain. It added a new system. for updates instead of fixed updates and added updates effect for it. Okay, that makes more sense. I think that's actually valid. So let's see. It added this. So this is what it did. So initially, remember, I moved this update effect from here. I added it to the front of this. So, but I think one of the things it changed here is to move it from the fixed update to add it to update automatically. So this still doesn't work. It renders a bit very, very late. It still doesn't work. I just felt it's not going to work. So that renders very, very late. So that means the issue is not fixed yet. And it moved it to a new system and added it to the update. Added it to the update so that the update effect runs if the game state is playing. So I think there's no point moving it here. Just add it here instead. You just add it to this. Since it's the same thing, all of them should work like this. You don't need this. You don't need this. You don't need this separate. I'm just comment this out. We really don't need this as a separate system added. So let me update this. Of course, nothing is going to change, right? Nothing is going to change because it's still the same thing. We are not even changing the functions to run in parallel, to run in sequence. They are still going to run in parallel right now, but that's not what we want. So in this case now, this is still the same thing. Nothing is changing. Literally nothing is changing at this point. So annoying. Okay, so let's go back and make this fix. So we need to check what else. Mhm. So I'm trying to just think of where this might be coming from. As that's basically what I'm trying to look at. I know it's not coming from the new functions that was added. It's actually coming from a place where I'm not seeing right now. I should see. I'm wondering why I'm not seeing it. You know what? I'm going to go to this place. Apply velocity. Yeah, what happens here? Apply velocity translates. Yeah, let's see. Where do we use velocity here? Where do we use it in the ball query? Yep. Where did we spawn the ball? I need to see where this is. Yeah, this is the ball. So velocity was applied here, multiplied by the ball speed. Yeah, so I think I'm right with this change. I just did. Where was the change again? No. Still not right. But yeah, I want to see what happens here. I'm just debugging this. Right? It's not like I have an idea. This is where it's coming from. Everything seems fine to me, but then it's something we are missing that is not making work clearly. So we need to find a way to remove that, to check, and debug the entire thing until we see the result of the resulting issue. So the issue right now I can think of is because it is like rendering very late. That's why it's not working as supposed to. So the update is not being done the way I expected to happen, which is sad at this point because this makes no sense. We are using the fixed this on enter of the game. Okay, let's see. So I didn't change anything from here. This is just still the same thing that was done before. Run if the game state is paused. That's for the undo menu paused, which perfectly works for updates. Run in state game.playing. Update effect. Apply velocity if the game is playing, which is correct. So apply velocity is where the ball moves, which should be moving. Currently not moving. Check the system again. So see if anything has been added to the ball. So far, I don't see anything like that happening here. Let me check the velocity to be sure. This. So for the ball, we added the transformation. Nothing changed here, so this should not be affected. It's the rendering time, the time it takes to render. That's the problem. Rendering of this has caused some issues. Or what was changed? Tell me. Let me see what was changed. I need to see it. Active effect default, effect timer. This. Okay, plugin skills. Let's see if it works. Oh my god, I'm just trying to make this as fun as possible. We've learned a lot. Let's see if we can actually implement something that makes sense. Yeah. Try to run an event handler, but there's no handler. Oh my gosh. What did I remove from there? Caused a panic without applying the file. Oh no. Effect timers. So wait, this is when it restarts. At this point of restarting, this has not even been rendered yet because this only renders when the game is playing. Okay. Okay. Have something else in mind. Navigate to duplicates. But it still doesn't matter because the resources did the same thing. We literally created the same resources here. Game state, high score, and still added the restart here, and it has been working fine. So that shouldn't be a problem. High score 0, 0, 0. Do you even need to duplicate resources here then? Let's take it one at a time. Let's not think about the restart first of all. We can implement the restart to check it out. Let's even get it to work as it's supposed to. If it doesn't render immediately, then still having the same issue. Yeah, still the same problem. Think. What can be the issue here? It's rendering too late, like lots too late. It's supposed to start on it, so why is it not starting? Why doesn't it start on its own? Why do I have to make any change? That's not what we want, clearly. Okay. What else do I need? Apply some power effects if present. So if this the fireball, this and this. Same thing, no. What is happening here? No, not what I want. Let me take a different approach. All right, so so I'm going to give this to client. I tell it to check. Okay, let's see if this can help by making it faster. While I keep looking at what I feel might be wrong, I just feel like that will see the issue way faster for me. Because now it loads very, very slowly. So the first thing you see based on what this gave us, is I need to analyze this. Looking at the setup, I can see the pattern is spawned as a sprite with color. The ball is spawned as a mesh 2D. For the rendering delay, you shall notice the pattern should render immediately. Exactly. And everything seems fine. There's no change around the. Exactly. Did it not change the initial? Okay, it's usually the initial board direction, which is different from the board direction. Now, let's look for the board direction. Make a change. Did it make a change here? Wow. Initial board change. Now, this is actually correct. That was close. I can see it. It says it uses this as a velocity initial this issue. I can modify rendering delay, use mesh 2D and second loading delay compared to sprite entities. All movements the system are really fixed up with special timing so when the rendering points compared to like okay, so just to be on the safe side. I like the fixed update thing, but I probably that's the issue truly. But like I said, that might not even be the thing. It might be this. I don't know. It depends. This is just the way of debugging stuff like this. You can't really be sure what the issue is. And I've not like gone through everything it's doing up line by line. Just trying to skip to see based on my knowledge of this. But the interesting thing is, yes, this is the fun of programming and and the bane of programming at the same time. Still not working as I expected, still not being spawned, but still not working as expected. So still definitely not that fixed update thing. So let's look at this. We said the stepping plugin might be affecting the timing at this percentage, but there's no change to the stepping, right? We only checked all of these things. It's not there. So the shop stepping plugin is designed for debugging and interface with normal game execution at 50, 35, 50%. Okay, okay. So if I remove the stepping, okay, okay. I think I can work with that because we don't really need to. We have the mode stepping, but we are not using it. So if I remove this, it shouldn't affect it for debugging purposes. True. So it says removing it, verify system configuration. Assuming give me a configure to run this. If you run the fix updates to your system in update. Okay, so this is not even the fix. Still the same thing. It's not working. No, this is not working as I wanted. Okay. Okay, so let's see. Okay, so let's see what this does. Let's see if you can perform magic instead of what the first one is doing. Because right now, if I'm to debug this, I'll have to go through this, and I really can't determine where the issue is coming from. I have my guess, but that doesn't change the fact that the ball is being rendered in apply. The multiplier, where does the multiplier get affected? To be honest, let's see. Because the multiplier speed should affect it only when it gets it. So how are you affecting the multiplier? How are you affecting the game speed if the multiplier if it stays in the constant? Right, that might be the problem here. Let's see. Before you do this, just hold on for this AI. Let's see if I can resolve this based on what just came to my head now. Apply power up effect. Let's see. So if it does the effect, is adding the active effect of paddle size? No, not the size. The ball speed. Ball speed multiplier equals to 1.5. the reset if it's faster ball speed multiplier, active effect. How does it seem a bit fishy to me? Because this ball speed should increase by the active effect. But the question here is, I don't really buy the dated plan. Convert ball to sprite, yeah, that's fine, but that's not the issue. Update apply velocity to use time, not really the issue too. Remove unused mesh material from setup, not the problem. This is not the fix. This is not the fix. Yeah, just give me what you think should make it faster, not the actual fix. But why it is not updating this? Update effect, yes. Apply power up effect, yes. Update effect, yes. There's the ball speed. And then the paddle transformation, not the paddle, ball transformation. So, okay, let's say I think this is where it's coming from. So, for the ball transform now, you get that from the ball query. The ball query takes in the with ball and without paddle. Paddle query is with paddle. Should I do without ball? That was where the problem is coming from. I still think this is where the problem is without ball. Let's see if I'm right or wrong. I can't be sure right now. Yeah, still the same thing. So that is not the entire fix, but it has something to do with the fix, I believe. Strongly believe that's one of the things. So yes, so the ball query here, we use it here to we destructure this, we get the ball transform and the velocity ball velocity from the ball query because we are working with transfer velocity with the ball without the paddle, which is correct. Yeah. And then we go to the ball query, we pick these two, but we need the ball transform is currently ball diameter multiplied by the active effect of ball size multiplier. Okay, that's fine. The scale is the same, extend by 1, which is fine. Okay, which is fine. Update velocity magnitude, which is the speed at which it runs. The current speed, update velocity magnitude, the current speed is ball velocity dot 0 dot length. Definitely not what I want to do here. That's the bug. I strongly believe the problem is coming from here. I 100% believe it. Two things I can do is comment this out, rerun the code. It should work. If it doesn't work, then we come back to debug it. But let's see if this we can print this and then we can look for the current speed from our terminal and see if it works. So the current speed is 0. Yeah. So that's where the problem is coming from. So current speed is 800 initially, then it goes back to 0 and doesn't move at all. And it keeps rendering 0 until it probably crashes and then recovers and then displays that, which that's the problem. That's terrible. So that is why. That's literally why it's failing. So I knew this was just plain wrong. The suggestion this was giving me was just unnecessary. We don't need those things. So now that we figure out where the issue is coming from, if we remove this for loop here and do this, restart this, we should get our actual implementation back. I'm sure. 100%. And it should work except for, so every other thing should work except for the ball effects. Now you can see this. But now considering this now, the paddle doesn't work still because the paddle still hasn't been rendered. So that means the problem cascade not just to the ball, but to the paddle as well. So it has everything to do. And two things, you notice this, that the effect doesn't even work for any of them. There's no way to know which one has effect or not. Okay, I didn't consider it. Okay, now you see, now that works. You can see the ball increase, right? That means we just hit one of the brick with padding, and then we hit the fireball just now. You can see that means we hit the fireball. You can see it moving. So every other thing works, and the timer works. But we need more feedback loop to be sure that it works the same way we want. But until we can do that, our power up is working. And that's impressive, but not exactly. So that means we still need to make a change to something. Two things, we already understand where the problem is coming from, right? And yes, we know how to fix it. Yes, so I can. So two things here. The paddle is late because of this code here. So what I'm going to say is, no, this is not where the problem issues are coming from. No. Just cancel this. The issues are from here. So I'm going to add this portion of the code to it, so you can use this information for both, for what it needs. And why it doesn't render the. Now, this is what I've been saying about AI for the past episode of this series. This is what it can do to you. You need to. That's why you do all of the lengthy first four series part of the series, because without going through the lengthy first four parts, we make mistake by it just gives us, oh, do this and do this. I'll just take it like that and use it. But that's not what we want. So in this case, we see that this is not what exactly what we want to see, right? So I'm going to tell it to check if it sees this. Just for now. So you guys just give me a minute. I need to pick something here. Just a minute. All right, I'm back. So let's see if this has completely done what we expect it to do. So the first thing here is let's see if it has successfully done this. We have the proposed solution here. Okay, so it finally agreed that yes, it was wrong. Yeah, so you see, finally we got the we found the issue and now it agrees that it's right. So the rendering delay issue, the problem is part of the update effects function, which is the paddle transform in the mute paddle query. And the paddle transform dot scale dot x equals the paddle size dot x multiplied by the active. So it says keep y constant here, which is same thing we have here, nothing too different. So the next thing here is this is where the problem is coming from. We already know this is not what we need to check. It says the issue here is this run every frame in the update schedule and it's constantly overwriting the scale of both this and this, which is very true. So the update function runs immediately and overrides the scale every frame. This constant modification, according to what is here, it says the constant modification can cause rendering delays as the entities are being updated every frame, which now is actually seeing the issue here. So the ball movement issue is the same thing. Yes. So the fix is this: you only update scales and when effect actually change, not every frame. Here's what needs to be fixed. Only update scales when effect changes. Instead of constantly overwriting scales, you update them when the multiplier changes. So I'm going to copy this. So I'm going to copy this because I want to give it to the AI that actually did implementation. And I'll tell it to paste this. The issues are from here. The issues are from here. So let's go back to read through all of these issues, effects this one gives to us, and the updates rather. The proposed one is, sorry for the scroll thing. I don't have much room space based on the fact that I increased the screen, the size to be this big. So we need to track when effect changes. So we will apply updates. So the first thing we need to do is proposed solution is go to active effect and update the effect only when needed, which I actually agree with this. Now I agree with this solution because now I believe this solution is a bit better. I agree with this because I trust this solution. Now I know that the error is coming from here and not just based on what AI just thinks is the error at this point. So as much as yes, AI is an active, is a catalyst and is a booster of whatever productivity you're currently with. it still needs you to guide it. So please, let's keep that in mind. So you go crazy with it. You see a lot of things on people like, oh, I wrote this, I wrote this. Yes, but in practical terms and in practical use, if you don't understand what you're trying to do, this is not you building a web page, right? Building a web page is now easy for AI to do, like in a flash. But building something like this, you're working with other things like this, is not the same as what you see online. So please, let's be careful about that. This is actual practical stuff, and you can see it live as to what you see, right? From the code he implemented, and it's telling me this is where the error is coming from. I had to check and say, no, this is where it is. That's how to actually use AI in the real sense. So we are not anywhere close to all the claims we see online. But yeah, that aside, let's proceed. So I'm going to ask the AI to now, based on the fact that I already know where the issue is coming from, I will tell it, make the fix from here, get the fix done. Let's see what we get back. So let's wait for this to be done. Let's wait for this implementation and see what we get back. So it's definitely not from the stepping function itself. So even for the stepping function, it assumed was the problem, wasn't the problem. So we already realized that the render, but we see that the effect works. If there's anything we've taken from here, is that the effects now work, and we can be proud of the fact that the effect works the way we want. See, we saw the effect work for when we restart. If I restart, the fireball works, right? Because when the fireball is activated, you can see the effect already works for paddle because it's bigger than usual, right? And that's not the only thing. After some time, it goes back to your normal position. Now you can see it goes out to normal position, and the fireball activates immediately and it clears all the ball at once. So we've been able to successfully get it to do what we want and see how fast that is. That makes a lot more sense, right? So let's see what this does. The rendering delay have been resolved. Problems like condition bounds were using fixed sizes. Exactly. Instead of dynamically scaled. Exactly. Fixed sizes should not be used. Now let's see if this works. Let me see these changes it made. Let's check this. Why did you have to remove my console log? I need it for my check. You are not really that trustworthy. Okay, let's look at this. The left word is paddle. It's using the paddle size instead of paddle transform.scale. I still don't trust this. Let's give the benefit of doubt. I don't think this is the issue. Oh no. Okay, let's see. If this doesn't work, I'll probably go with the other previous AI suggestion and use that previous approach so we can keep track of what is actually moving. This seems too good to be true. If it works here, that's cool, but I really don't want to believe that is the issue right here. Yeah, like I said, that is not the problem. It's so obvious it's not the problem. I don't know what this is doing. So the ball is going to load and just remain in the middle now. So yeah, same way as it was before. Doesn't do what we want. Let me ask a question. Let me get this and say, would you like me to implement this fix? Will you be able to implement this fix? In fact, I need to restore what you did. I don't really like this implementation you did at all. I don't like that. So you added the ball diameter to this. That's 535. Let's see. 535. I don't like this. Take it back. Take it back. Yeah, load file system changes. Yeah, load file system changes for me. So let's see the next change. I'm reverting it back to what it was before, 492. I don't trust what it did there. It doesn't seem right to me. Okay, so that's fine. So yeah, another case of it spoiling my code and me getting to fix it myself. Blah blah blah. AI making mistakes. Part 4. All right, so yeah, let's let this implement. Yes, implement this fix. So first things first, I'm going to add a branch, and I'm going to call the branch breakout power ups, because the feature, and I'm going to check out the branch. So now I have all my fashion files, which is just one. So what I'm going to do now is I'm going to commit this because I know what it is. So I'm going to commit it to see what we have. Our light generates a commit message for me. So this is where I optimize my workflow. I literally don't need to think of the commit message. Come on, where's the commit message? Okay, done. So commit message here. I'm going to commit this before making, because I know this works, right? So any other changes I'm trying to make now is just going to either break or I can just revert straight away. So yes, implement this fix. So yeah, so let's see if this fix is going to work, because this eliminates the rendering delays and overrides. Let's see what this is going to work with. I don't trust this as much too, but yeah, let's see. It might just work for our use case and it might not work for what we want. But let's give it time to implement this. So I'm going to toggle the act mode and see what we get in return. Okay, so we have this tracking the previous paddle sizes and the new paddle sizes. So now let's allow it do its thing. So the first shot we did, the first one shot we did was quite quite impressive. I was not expecting it to work once, but it did work once. And from what we see, like I said, we already now see that the effect works, right? We have effects. The effects we implemented, the paddle size increase, reduction, the paddle enlargement or reduction works. The ball size, we've not seen the ball size work, but we've seen it implement the fireball completely. So that means our effect works to an extent. Not all of them, but it works. And before we start doing other things like other what they call it now, other UI effects and other particle effects, before we can start taking about particle effects. These are things we can also add to it, or we can check first of all to be sure that functionality works before starting particle effect. We can add things to the ball like fire trailing the ball. It's possible. That's possible, but that's not our that's not what we want to do for now. We want to actually make sure this works the way we intend it to work, right? See if it can spawn the ball and the paddle the way it usually does it before without any issues. And if that works, all well and good. If it doesn't work, we know that we are back to fixing the implementation again, right? So those are updates and those are choices we need to make. But then let's see if this works. Um, let's give it the benefit of doubt and see. Okay, so while we wait, I think this is almost done. Why is he running this? Just run it. Then there are multiple implementations. Yes, there are. All right, so this is the fun part of AI. You knowing what you are doing. If not, you get frustrated. Trust me, like you will definitely get frustrated. AI is cool and all, but Jesus, you get frustrated working with it if you don't know what you are doing. So just I think it's important to always discuss these parts that we don't see online most times. And yeah, so that is important. And also, if you're enjoying this video till now, if you're enjoying any part of this series, please consider liking this, also subscribing so that you, as we work on more things, right? Because I work on other aspect of, I do a lot of other videos as well on Rust, on actual mobile development, like because that's my main daily driver. Most times I work a lot with TypeScript, aside from in this case. So if you're interested in that also, you know someone that is interested, you can also tell them about it. I'm going to be working more on after we are done with this series, I'll plan another series for probably the next few weeks on something entirely different and work on with Rust. Or if you guys have any other suggestions, feel free to drop it and I can always reach out. So and while we still wait for this to be complete, and this has completed the module for me that it should not remove. Why is it defining physics? I don't even want you to use physics here. I know it's there. I didn't want you to use it for crying out loud. Jeez. See? Problems. So yeah, back to what I was saying. If you know someone that's interested, also I have other series on mobile development, on gaming, on implementing other things, other web stuff that are not conventional, like adding things that really nobody want to talk about out there, or you don't really see people talking about much as well. Like let's see how long it will take us to build a mobile app or something. I know now Cloud can do that, but then what's the quality of what it's giving out? You want to learn how to build stuff quality wise and having questions and all of those things. Yes, we can implement all of that. So yeah. So those are the things we are trying to do or implement at this point. So yes, if you are enjoying this, consider liking this. I really appreciate that. This guy is just hallucinating. This is why I hate using this model. It just keeps hallucinating for no reason, for no simple reason. Like you've done the main thing. Why do you have to spoil it by looking at what you don't even concern you with? I told you to use one while you are using four. Come on. Now after doing all this nonsense, I'm going to have to go clean it up again. Looking for physics. Why? What's your business with the physics of that race there? That's not your issue to deal with. Wow. Okay, I think I know what I'm going to do here. I'm going to just let's see. Before it runs this, I'm going to restore to this point. I don't want it to run anything. Active effects. Okay, so let's rerun this, restart this, and see what we get because we're almost there. I have this feeling we're almost there. So currently we've implemented all the effects. The only thing we need to do is fix this rendering issue. Once we are done with this, then our effects power-ups work. Our power-ups work for our game. Finally. Yeah, it works. So you can see you can see this movement. You can see that the ball is slower, right? So you can see it's bigger. Yes. So finally, we know that all the effects are working. But we need a way to be able to track what effects, and you can see that it's faster. And after a while, it reverts the original size. You can see it's faster again. Then the size goes back. Then the fireball works. Now you can see all of these things changing. So it successfully gets it to work. Yes. So now our power-ups implementation works perfectly, especially the fireball. The fireball is like one of the coolest implementation. It just clears everything at once, which is cool, right? Like very cool. Yes, and within a few seconds, we've already completed all of this. So what next can we do about this? Let's see what next we can do. Finally, we get it working. So yeah, kudos to AI for that. But actually, me, not the AI, because it did a lot of nonsense. But then it still tried to help us make it faster, which is cool. So we successfully got this working. What's the next thing we can do now? Let's talk about the levels. So I'm going to I'm going to add this to let's generate a commit message for this and call it, I don't know, let AI generate it for me. And so we successfully implemented that. We have more things. It's not perfect yet. So like we want to add, okay, so this would be an issue because we don't have icons, we don't have assets to define which of the to define which of the bricks have. I guys think what I'm thinking. Okay, let's do that. So first thing we're going to do is we're going to use this implementation. We're going to say that, okay, we want to add the power-ups, right, to any of the bricks that have the power-ups. And we want the power-ups to, want it to be displayed, or your text to be displayed probably by the left of the screen, just like we have here. So I'm going to restart the game. We already have all of the implementations. The R for restart, escape for pausing the game, all of those things still works. And we don't need to like bother about it. So we want to actually add other things like when you can see the ball works. So we want to have things like whenever any of these things happen, you should have a UI that displays and say, oh, power up has been added, speed has been added, just to give the user a feel of something has changed. Because if you don't really know, you won't know what has changed, except for the ball size increasing, yes, and the fireball size changing. So what we can do is I will tell it to make some changes. Now, the first thing I'm going to say is let's see what we want to do. So okay, let's see the change I want to make. The changes I want to make here. So one of the changes I want to make here is I'm going to continue using client so you guys can see what's actually happening. Is I'm going to say, okay, this works. Oh, it works now. This is cool. I want to make some changes though. One. the there should be a text UI that tells the user what has changed. For example, if the user has, if the um, large, the paddle, what's the word? I want to be sure I'm using the right thing. The paddle size multiplier power up type. Yes, the long paddle effect has been added. Um, indicates that long paddle added. This will help players understand what has changed and what has not changed. Right? That's the first thing. The second thing I want to add is from this implementation we see here. I want to change the ball color to red to a bright red color with, okay, let's say bright red color to indicate that when the fireball effect power up is assigned to our ball, this will give the illusion that the ball has activated a power up. This makes sense, right? So this is what we are going to do. Change the ball color. Then let's do the third thing. The third thing is just going to be, okay, let's stick to these two. Let's see how it's going to implement these two. Let's see first of all. Okay, so it has suggested some things. Let's see. The first one is no, don't try doing this. I told you it worked already. Okay, so let's see this one. Next thing, which is the before shows this, the after only when the effect changes. Okay, yes. So for the power up now, we have the power up notification, we have the fireball visual effect. So, so the fireball visual effect also will work. So the second thing we need to do is change the ball's color to a bright red orange here, which should, yeah, okay, let's implement this. Let's implement this. Okay, let's do this. Let's say act upon it and let's see what it does. All right. Sorry guys. I think yeah, we're back now. So the next thing is this. We already have this. So let's see if this actually fixes the issue, right? We are not really sure if this does, but let's test it out. There's no way to be sure until we are sure. So it doesn't really write anything. But we can see the effects working in real time, but nothing has been added to the code I see from here. It only tells me that it is implemented without implementing anything. That's weird. I just told you what to do and you didn't even do it. You're telling me if there's any other thing. Power up notifications UI. You didn't implement the new feature request at all. Why? So that's always the problem. And interestingly, you might just give me the same thing back and say, oh yes, I've done that without making any change. Yeah, he's telling me I got caught up for something. What did you get caught up doing? I got caught up in the success of the fix and moved directly to completion. That's so weird. Okay, now let's try this and let's see if it works. So implementation strategy is written. Let's see if you can follow it step by step and get that implemented. So I start with phase one, the fireball core, since that's the foundation. Yes. Sounds good. Proceed with the implementation. So well, it's good to know that our so you can see change time, right? So that means we believe that everything works. So I think we didn't have enough of the fireball here. If not, you should have cleared this by now. Fireball just makes your work easier. There's the other things we can, the other power-ups I'm trying to remember when I used to play the breakout game that year. And there are a lot of things we have, a lot of power-ups. Um, a lot of power-ups I always use. I really can't remember some of them now, but I know I always like the fireball, which is why I remember that even without having to think twice, I definitely remember the fireball. The other ones, I think there's ice ball or something. I don't know what that does. I can't remember if it does anything. There's this green one that's okay. Yeah, there's a splitter ball. I think that those two were my favorite. The fireball and the splitter. The splitter can really help you because it splits the ball in two. So instead of one ball, you have two or three. I think it gives you three, yeah, by default, the one I played. So we can implement that or add that to our, let's say we add that to our set our effect, right? Let's have a splitter or yeah, let's call it a splitter, a ball splitter or something. I don't know. Just give it any name that it will implement. And so far so good. We can see that that is the wow, really you're not done. Okay, yes, stop good this and let's see if it can proceed. So let's see if this can be fully rendered by this guy without going offline or going haywire or just hallucinating with the implementation. We expect it to be done as as perfect as possible. So let's see if that works. Let's see if that's can be completed from start to finish, right? For this. So that's what we intend to do. So yeah, so far everything is fine here. This is why are you taking time to implement this now? And this is taking so long to write any of these things. And guys, sorry for the background noises. Been trying to like prevent the noises, but it's been a lot. So uh oh, finally, it's moving again. Let's see if it's going to complete this. Okay, if it doesn't edit it now, I'm just going to cancel. Okay, so it's working now. Finally. Okay, so that means it's able to implement this. Let's see what we have. I think my background noise is fully reduced now, so sorry about the noises. It's a weekend, so there's a lot of activity around. So what did you spoil here? I can see my red lines everywhere. Okay, I really dislike when this thing just goes ahead and spoil the entire code for me. This makes no sense. It's not going to fix this. I already see it. It's not going to fix this. The moment it starts hallucinating like that, it gets worse. It gets worse along the way. So I'll probably just tell it to write the plan for me. So we're rounding up this shortly as well. Like I just want us to finish this implementation so you guys can see and understand the new things that we've tried to implement since we started this, right? Um, so yeah, this is me trying to get it to implement the last stage of what we are trying to do here before we wrap up with this series. Because to complete this seed working, then we do that as well. Hopefully it will write what I want it to write. Like it's just so terrible when you want AI to do something for you and it just keeps misbehaving, telling you have done it without doing anything. Seriously annoying. I'm literally on plan mode. Yes. Finally, it's writing it. So you can use this to you can pass this file into another LLM. These are shortcuts you can use. This is what I use to run all the free models I run and it works. So I just pass I get a very detailed implementation, pass that detailed implementation to different LLMs. If I see one hallucinate, I get into what I want. I try another one. Hopefully one will be able to give you what you want. That's basically how to go about it. So in this case of it's implementing something I want now. If the first one doesn't implement it the way I want, I move to the second one to implement it the way I want. And that's the flow and that's the approach I use. So in this case now, this is how he's going to do it. So he knows what to do. And even if this doesn't fix it, because I don't believe this LLM should be able to fix this, I'll just switch to another LLM that will be able to fix this for me straight away. So now this will tell me that, oh yes, I'm done with this. Toggle so I can begin implementation. I don't want to be to implement anything. So just pause. So I'm going to give it to a new LLM and say that, okay, Fireball some contains updates I want to implement to Breakout.rs. Can you implement this update? So while we wait, this is what we still have. So let's go back to this. We can see that this is what we have now. Everything works fine. The fireball works, the speed works, the size of the ball can be increased. You can see the paddle size increasing. See how fast it was to complete that level. So that's the essence of power-ups. It makes it more difficult, or way easier for you. And besides, you don't know what you get. So if you get something that will prevent you, yes. If you get something that helps you, also good. So that's exactly what we are trying to do in this case. So if you can fully get this to work as we expect it to work right now, then we can be sure that okay, the um this will give us the updates we want, right? We can get the updates the way we plan it to. And then if there are any issues, we can always resolve it just like we did the previous one, using our knowledge of how Bevy works and how Rust works, right? So just basic knowledge of what we understand from it. So if we understand what they're supposed to do, we can get them to work, and that is it. So now, if you see this now, this is already providing me what it thinks should be used. It's even suggesting how to add glow effect. Well, we are not adding glow effect, but we should be able to fix that. So and there are errors that I really don't want to see here. Hopefully, you can fix these errors. But I think it's just implementing precautions at this point. I seriously hope you can fix this. But then if it doesn't, we'll fix it ourselves also. But I don't want us to waste time. I wanted to wrap up this and complete it in the shortest time possible. Because we've already seen how what we can implement here, right? By looking at this. You can see the effects being implemented. All we want to do is just add the text to it and the UI changes, some UI changes for that. And this is fun, right? You can see the power up in real time, working, adding to it, changing the size, the length of the length of the paddle, increasing the length, reducing the length, increasing the speed of the ball, increasing the size of the ball, and giving it the fireball. If it has actually hit any fireball, we can just see it automatically. So that means we've seen the double size ball twice now, and we've seen that work. So the double size doesn't really do anything aside from give you much room to be able to hit more balls at the same time, or more bricks at the same time. That's what it does. So the speed is increased, and now it's reduced. The spawn recursive doesn't work. There's no spawn recursive. You guys just keep writing nonsense here. Notification, no timer. Cannot borrow immutable local variable. That's mutable. So we're using a mutable reference. Why is it complaining here? What are we doing here? So let me get what is happening. Power up notation is coming from query dot header. I know it doesn't need to be mutable, but then we need the mutability here. So what is the problem? You say it doesn't need to be mutable, you say it needs to be mutable. Okay, I think I know what is happening. Cargo check, wrong cargo check. Something is wrong. Okay, so we need to make changes here. It should take in 4 values, if I'm not mistaken. Oh yeah, it should take in 3 values rather. There was the error coming from? Convert color from this, creating color from this using this. The red channel sRGB dot this color dot into. So what's the issue here? Convert color material from traits. Ball color from traits. Okay, we need to fix that notification timer thing. So we are gradually coming to the end of the implementation, right? So we already know that we have this implemented. We need to get single. There's no get single here. There's only single, if I'm not mistaken. Yeah. There's only single. There's no get single anymore. You just told me you understand how Bevy works, and this is the best you can come with. It's being used after being moved. So we need to change this. He said now because the cause of that is ball query dot into. Oh yeah, that's because the value has been moved here. Big problem. So the value is moved here, and let's see what it is first of all. So this is the only issue left. Cannot borrow mutable local variable. Make notification mutable. Remove this mutability, and then it complains again. Notification dot timer dot tick. Oh, this works. This simply worked. So why is this just giving this unnecessary issue here? So we pass this to the last one is this one. Apply power up effect, which is the poll query. Which is a problem. How do I fix this? Hopefully you can give me something that works. All right, I'm coming close to the end of this series. Coming to the end, coming to the end, coming to the end. What's the first thing? What's the next thing? How do we fix this? You have a fix in mind? Let's see. So hopefully this should be able to generate all the other fixes we need. And this is taking time too. Oh my God. Okay, this have an idea. So we have a query here, and the bulk query simply does this. So we need this one to be single entity mute, which is literally the same thing. Entity velocity transform. I'm sure this will not cause issues here. Okay, let's assume it won't, right? Because I definitely think it's going to. Yeah, it's going to. So mute ball entity first. So let's structure it. Structuring successful. So the main issue. Instead of use ball entity instead. So instead of that, let's see what we use. So for where does this? Where do we even have this? Apply power up effect. So we need to use ball instead of ball. Okay, so that was correct. Ball entity is correct. But it's expecting something else, so we need to add that to this guy. Apply power ups. So first things first, I'm going to copy this just in case it misbehaves to go to the wrong place. Okay. Oh, nice. So what we do next is we have the ball entity instead, and that should, well, I think, solve it. Like I said, we are literally just adding updates here. I changed it from using queries to using just entity, which is strange. But if it works, that would be nice. Then from there to using bulk entity instead of bulk query. To implement the insert, add fireball component to ball. Fireball active component to ball, which is let's okay ball entity custom ball query should be ball entity in this case, but it's not going to be single, so we can't use that. So we need to add ball entity dot insert command dot entity If this is here, we can just post this here. This is literally the same thing. Okay, benefit of doubt, check. Let's see if it works. Let's see. Does it work? Does it work? Before we wrap up. So we might not be able to implement the level systems, but at least every other thing we plan to do is working. So it's something. This is something I can also add to it. Let's see if it works at any point in time. I really doubt it's going to work. Doesn't seem like it added it. Yeah, it doesn't show the text, so yeah, that failed. Let's see if the fireball worked. Just waiting to get one fireball effect or power up. Then we can be sure if it works or not. We can know. Otherwise, we can't find out if it works just by looking at it like this. Every other power up has been gotten except for the fireball. Now that we need it, you can't get it. That's strange. And also, you can notice that the ball gets smaller also. Like there's a smaller ball, there's a bigger one, and there's the medium, the normal size ball. So yep. All right, so that doesn't work, but then it's something we can always fix, right? I know we can always implement that. So what I'm going to do is definitely we are done with this, and this has been fun working with it on with you guys. So yes, this is going to be the end of the series, and hopefully you guys have learned a lot, not just a little, not just a bit about Bevy, a lot about Bevy and Rust, and what you can do with them. And you can see it's us implement to the 3D sprite animations, subtle things that you need for to start your game development journey. So I strictly and I want to believe that this has been helpful to you guys. It has really been helpful to me too, right? Because I learned also from all of this. As much as I'm the one explaining and implementing these things, or writing and combining, giving the ideas and suggestions, I'm also learning from it. So we've been able to learn together, which is the aim of this series. So to every one of you that has participated in this, thank you for participating. It has been fun, it has been engaging. And like I said, if you have any question, feel free to drop a comment and I will attend to it. No matter what it is, just drop that or ask the questions, drop a comment, like. And I also appreciate if you guys like the video just to show that yes, you guys appreciate what is happening here. And if you don't mind, you can also subscribe so that it gives that sense of, oh yeah, this is nice. People are really finding value in this. So I really appreciate if you guys do all of those things. But once again, the main aim of this is to make sure we learn together from this. And I believe we've done that from this video. So thank you so much, guys, for watching. Thank you for being a part of this series. And like I said, there are more series that are going to come up. So if you want to be aware of those series, just make sure you follow, subscribe so that you can get notified when those things happen. And from tomorrow, in fact, there's going to be a new series, but that's not going to be a Rust series. It's going to be a different series entirely, different language entirely. But if you're interested in any other language or you just like to explore different languages, yeah, feel free to join also. Tomorrow we are kickstarting a new series, not Rust, but we are going to bring again another Rust series, probably in the next week, in the coming week. That's after a week now. Just the way we treated this in a week, we are going to prepare for that, and then I'll drop an update, a post that indicates that. So feel free to subscribe so you don't miss all of these updates. So yeah, thank you so much once again. Feel free to share this video to someone that you feel needs it, someone that should learn from this as well. And catch you guys in the next one. Bye for now.